Hey everyone, Grand K for the Flame Learning channel. In the previous video, we looked at the PBR Shader node in great detail and saw how each parameter influenced the look of the texture. We also started getting into the PBS Map and how you could use it to drive the parameters of the shader node with images instead of numeric sliders. In this video, we start using the PBS Maps to illustrate some of the workflows that you'll definitely find interesting. The model I am currently using is courtesy of TurboSquid. You can purchase this model and many others by visiting their website at www.turbosquid.com. So the first workflow would be driving a physical-based parameter using the pixel values in an image. You would typically use this to apply different looks and feels to either the entire texture or parts of the texture. This can actually be any media. It could be from CGI, camera footage, stock footage, or even something generated in Flame. So let's create our own image map in Batch. Swipe back to Batch and go to the Batch node bin. Locate the substance noise node and drag it into the Batch schematic. In the file browser, load the Dirt2 substance noise preset. Double-click on the node and press F4 to see its result view. Now scale the pattern up to 250%. Your image textures can actually be any size you want. We'll also set the texture to 2K, so we'll have a better resolution to use with the PBR texture. Now using this image, you can scatter or randomize any parameter of the PBR shader. In this instance, we'll use this to scatter either the metallic or roughness value of the PBR texture. So let's bring this into action. Go back to Batch and select the Action node. Press Ctrl-N to create a new media input. Just connect the substance output into the front media input. Now go back into Action and call up the 2-up view. We want to use this image as a texture map and not an image object. So delete the newly created axis and surface from the Action schematic. Select the Material node. Go back to the Action node bin and select the texture map in the media list. Next, go to the Maps tab and locate the PBS map. Drag it into the Action schematic and it will attach to the selected Material node. Since this PBS map can represent any parameter, its default state is undefined. So double-click on the node for its controls. Let's start off by changing the parameter to metallic. The metallic property of the texture now has a blotchy or imperfect look. This is because the substance noise pattern affects the metallic value per pixel. Now you can adjust the metallic effect to increase or decrease the effect of the metallic quality of the PBR texture. You can also soften the pattern if it is too harsh on the texture. So this is great for introducing surface imperfections like scratching or aging a material if required. Now let's see what happens when we affect the roughness of the texture instead of the metallic properties. Switch the parameter from metallic to roughness. Set the effect to 100 and reset the softness to 0. When you use the image map on the roughness of the PBR material, the nature of the image pattern scatters the reflectivity all over the texture. In artistic terms, what you're seeing is a great example of adding rust to metal. You can then use the effects slider to control the intensity of the rust on the texture. Just bear in mind that the roughness can only exist between 0 and 1. So if you take the slider over 100, you will get some unpleasant looking results. Now I don't need to go through every PBS map option, but you get the general idea of how the image texture is driving the chosen PBR parameter. Now this is great and very flexible. However, it's affecting the entire texture. But let's say you wanted the rust look to only be present around the mouth and the nose of the lion. So the next workflow will show you just that. Now you have the entire batch toolset at your disposal to create these isolations. You can use masking, painting, or even compositing, but there is no wrong method. I'll use batch paint because I like the free flow nature of the tool. So swipe back to batch again and add a paint node after the substance noise. Now it's not necessary, but it's ideal to see what happens to the 3D geometry in action as we paint on the texture. Select the action node and call up the contextual menu. Choose Set as Next Available Context. Next, double-click on the paint node for its controls. Switch to the 2-up view with Alt-2. Select the right viewport and press Space 1 to see the action context, and select the left viewport and press F4 to see the painted result. If you're painting over a series of frames, a good reminder is to set the paint mode to paint over a sequence of frames and not just a single frame. Now we're affecting the roughness parameter of the PBR texture, but the behavior would be the same for any PBR parameter. The closer we are to white, increases the roughness. The closer we are to black, decreases the roughness. Now this texture has a bit of roughness, so we don't want to paint it completely black. So choose a 33% grey colour. Make the brush size bigger if required by holding S and dragging the cursor. When you start painting on the image, you'll see how the solid colour values control how roughness is applied to parts of the texture. This allows you to really take artistic control over how materials will look within the PBR texture. You can use any tools you like, even using different types of brushes, to blend the roughness pleasingly into the texture. As I said earlier, this will work with all types of PBR parameters you can work with within the PBS Map object. Looking back at the contextual view, you can see that the roughness is concentrated in a specific area based on the incoming texture map. Now let's go back to action and set the 2-up view back to result view and action schematic. If we select the PBS roughness map and toggle it on and off with the H keyboard shortcut, you will see that by combining the shader node with the PBS map gives you so much control. Now the beauty of PBS Maps is that you can have multiple nodes controlling different PBR parameters. I'll go ahead and add another PBS map to this material node. Now this PBS map is undefined for the moment. If we go to its controls, you can choose from a range of parameters. I just want to highlight some options at the bottom of the list. Firstly, you will find AO or ambient occlusion. I'll be covering this particular option in a separate video, as this allows you to load a pre-baked ambient occlusion within the physical-based rendering shader, and the indirect lighting results are very impressive. Second from the bottom is opacity. This can definitely create interesting results on the PBR texture map. For example, we'll leave the PBS map as undefined and go to the material node controls. In the surface menu, you have a transparency slider which controls the general opacity of the 3D geometry. But if you go back to the PBS map and change the material parameter to opacity, the transparency of the material will be based on the different luminance values of the associated image. So you can have varying levels of transparency on the 3D geometry. Decreasing or increasing the effects slider will control the overall transparency, but there will still be a differentiation based on the brightness of the PBS opacity map. Now, as a side tip, you might notice the artifacts in the semi-transparent geometry. Just go to each of the geometry nodes and change the sort mode from sort off to sort transparency. So if you orbit the camera in the 3D scene, the semi-transparent geometry should look correct. Finally, coming back to the PBS Map Controls, at the bottom of the list, you will find the custom parameter. Very briefly, This is specific for developers who wish to create their own custom code within the PBR pipeline. So you could create additional looks and effects by adding your own PBS maps into the shader. Please refer to the Flame documentation for further information. Finally, it's important to point out that Flame on the Mac OS platform only has base color, roughness, metallic, AO, and opacity in the PBS map. This is unfortunately due to the graphics hardware limitation. But as you have seen in this video, there is still tons of potential functionality and creativity. Now, using the PBS maps with the shader node, you need to provide it with a texture that you either source or create yourself. If you don't have time to do this, your other alternative is to use the PBR substance textures. These textures are procedurally generated and exist within the Flame PBR shading model. They're fast, easy to use, and can create some incredible realistic textures. All of this will be covered in an upcoming video. Be sure to check out the other features, workflows, and updates to the Flame 2017 Extension 1 products. Comments, feedback, and suggestions are always welcome and appreciated. Thank you for watching, and please subscribe to the Flame Learning channel for future videos.